Okay guys, what I'll be doing today right now, at this moment, I will be basically reviewing this amp here, but more importantly I'll be actually doing measurements of what this amp can actually do, the benefits of this amp. It's one of the Powerbass line. Now before I carry on, I do know this comment or the statement will come across that this is not the Powerbass in the USA, and I will agree with that statement. This is not Powerbass USA, and for now I will leave it at that. Okay, so this is the line that we get here in South Africa. This particular one, the mini, it's the PB4800d 4-channel. Okay, it says there 5200 watts 4-channel, but obviously those are inflated figures. So I'm going to be testing and actually seeing what this thing can actually push RMS wise, both 2 ohms and 4 ohms and bridged. Okay, I will be doing basically 2 tests. I'll be doing what the amp can actually push at max gain, okay, before even after distortion, what the amp actually can produce at full gain, distortion or no distortion. I will be testing that, and then I will test what you can get out of the amp clean, a clean signal. So okay, let's now get this thing started. I'll be showing you the actual box and just now from a different angle. Okay, right now I'll be opening up the amp. Bear in mind guys, this will be my first, like you can say, like unboxing. I've never really done unboxing, so I might miss out some information, but I will try and stick to the main issue of this video, which is what the amp can actually do. That's the main thing. That's what people always ask. What's the watts of this and what's the watts of that, and then some people go online and they actually would quote the inflated numbers, and then other people will be like, but that doesn't make sense, you know. So the main focus will be the actual measuring of this amp. So as I open it up, as I stated that I did actually open this before to test on somebody else's car. As you can see there, it's quite a small, nice, nifty little amp. Okay, it's got 2 fuses. I don't know if you'll be able to see, but the fuses there, this is a 25 amp and 25 amp fuse. It's got Allen key terminals. As you can see, it's a 4-channel, and at the back there's your RCA option input, and then high input with that cable, so that you can go either way. You can either go RCA or this option here, using the actual radio to switch on and off, and then obviously your crossover. Okay, and then just put it here. Okay, and then what else you get? Okay, you get a sticker, a little Powerbass sticker, and then you get a little brochure. Okay, so the little bookie. Okay, so, and then the wiring options and all that stuff. So this book covers, if I'm not mistaken, this one, yeah, it covers it only covers this 4-channel amp. Yeah, it only covers a 4-channel amp, and then obviously we all know those little options in there. So now obviously going to test this. I don't know if there's any additional information here. Okay, here we go, the specs. Okay, so as it states here, okay, I don't know if you'll be able to see, it says RMS power at 14.4 volts. Okay, so 4 ohms, that's 300 watts times 4, At 2 ohms it's 450 watts times 4, which I doubt it will push that much, but we will test it and see. Bridged for your subwoofer, it will be 900 watts times 2, okay, at 4 ohms. Okay, obviously the other stuff here, the HPF, LPF, HPF. Interesting thing is the HPF and the LPF is at 40 hertz, basically the starting point or the ending point, depending on which setting, you know. Obviously for the HPF it will be the starting point, and the LPF it will be the ending point, depending on where you set it. And as it states there, fuse rating 25 amps times 2. Okay, and then obviously the dimensions of this thing. So right, so now I'll be testing this thing and just seeing what it can actually do. Okay, so the quickest way to actually check your watts on the amp is you take that value of 50 amps. Okay, so let me just open up the phone here quickly. Just go to the calculator. Right, so you take that that value of 50 amps, okay, and then you multiply it by 14.4. it gives you 720. Okay, so what I normally do is I work it out on 3 different measurements. So I work it on 14.4, the other one I work it out at 13 volts, which is 650, and the other one I work it out at worst case scenario of 12 volts, which is 600. So what you do is you take that value, because now it's a 4 channel, you take that value and you basically divide it by 2, because there's 2 fuses, each fuse for 2 channels basically. So you take that value and just divide it by 2. So in this case for 12 volt, 300 watts, well 300 amps, it'll be 300 watts per channel. Okay, and obviously that's, then you divide it again by 2, then each channel gets like 150 or something like that. But that's just a quick way of working it out. So yeah, now I'm just gonna show you guys the rest of the stuff. Okay, I've already connected the amp and the radio to my battery over here. So what I will be showing now is the actual tool I'll be using. You can either use a oscilloscope or you can just use a normal multimeter. Let me just show you. This is if you want to do it yourself, DIY yourself, you can use a multimeter. Only problem with the multimeter is you cannot see distortion, unfortunately. So for this example I'll be using the oscilloscope. Okay, so this is the oscilloscope. This is what I'll be using for the test. What I've already done is on the memory stick over here, I loaded a 50 hertz tone sine wave, and I've loaded a 1000 hertz tone. So obviously 50 will be for the bass, and then obviously the thousands will be for the normal like tweeters and mid bass going up. Okay, so I'll be doing that now, and then I'll be seeing you in a jiffy. Okay, so right now I've got it set up, and I've already done the settings here. So what's happening is there's a 50 Hertz tone playing here in the background. The radio is at basically the max just before clipping, and then my gain is down. This thing is set at HPF because I'm testing one of the channels. The bass boost is off. The HPF high pass filter is basically at its max, which is at 40. LPF won't work, so it's irrelevant because it's the amp is now set at HPF. So the tone that I'm using is a -7 dB tone. That will also affect your reading that you are getting, depending on which tone you're using. If you're using the way of the multimeter to set your gains and not by ear, obviously the higher you go, let's say for argument's sake I use a -5 dB and my music is actually playing at, let's say for instance, -20 dB, obviously there'll be a huge difference in that. But then if you're playing quality songs that actually also go up a little bit on dB as well, you'll be getting close to quality of your actual gain settings. So both of these tones I'll be using will be at -7 dB. So as you can see, it's playing the 50 Hertz. Okay, as you can see, it's fluctuating 49.50. So I'll be adjusting the gain, okay, first, just to see. Okay, it's going up. Okay, now I'm at 2 volts, 3 volts. Okay, funny enough, I'm not sure what's happening there with that 100 Hertz. It's something weird happening there with the amp, but right now that's basically full. It's looking quite like a weird wave. So it's at 3.184 volts. Okay, so I'm just gonna make that note quickly. And the interesting thing with this amp, traditionally you don't touch the bass boost, you don't touch it at all. But with this one here, you can actually get it and actually go higher, as you can see. Now I am at 6 volts. You see it's back to 50 Hertz, okay, in 14 volts. And the wave looks pretty clean. Yeah, it's starting to clip. That's basically the bass boost at max and the gain at max. Okay, so I just went a little bit back, so I'm getting a reading of 15 volts. Okay, so I'll just mark that down. Okay, so this is what I'm getting now with it per channel. Okay, so what I'll do is I'll just work it out. I just want to do this test quickly and just see. So now I'll be going over through to a 1000 Hertz tone, and let's just see what happens. Okay, it's just a reading. There you go, 1000 Hertz. Okay, this one will be a bit difficult to try and see any clipping, but the wave looks somewhat clean there. I'm reading 8.7 volts. I think the 50 Hertz is maybe a 5 dB track, but I know for a fact the 1000 Hertz is -7 dB. It's just sometimes when you look at the graph, they look similar. So this one is a bit less now, 8.71 volts. Okay, so let me just make a note of that. Now, like I said, traditionally you don't touch the bass boost at all. And the interesting thing about a bass boost is it only boosts 45 hertz, 50, 55 hertz, in that region. That's where the boost is coming from. Automatically, also what would explain why I had a 13 volt reading is because I'm playing a 50 hertz tone, and obviously the bass boost is boosting 50 hertz, so obviously automatically my voltage will go up on that region. So now that I think of it, it makes sense why the voltage will drop here and it will be higher at 50 hertz. So bass boost doesn't boost all the frequencies, guys. It just boosts like 45, 50, 55. You can maybe cheat a little bit. It might go maybe 58, 59, or it might go closer to the 40s, but in general that's where it boosts. So yeah, okay, at least there I kind of now understand and know what actually happened there with the voltage. Now I'm gonna just turn it down a little bit. Now I'll be doing the actual bridge side. Okay, so I'll just be back in a jiffy. Let me just do some adjustments. Okay, so now I've got the thing bridged. Okay, so now I want to see again 50, it'll be 50 hertz tone. Unfortunately now I don't have, I think I've got a 90 hertz, but I can't remember at what dB that 90 hertz is. So the 50 watts will be somewhat higher in voltage, because if I'm going to go to the bass boost now, it's going to be high in voltage. But under normal circumstances with the gain, we'll see how much this thing can actually push. So right now, let me just, I've already done the settings, so what I need to do here is the LPF has to be at its max over here. Okay, so now I'm fine. Now I'll be adjusting the gain. Let's just see here. So okay, it's going up 4 volts. Okay, I'm getting 8 volts. Okay, now 8 volts without any bass boost. Okay, and it's looking quite clean. Okay, so now I will be doing the bass boost. Okay, and like I said, bear in mind it only boosts those area frequencies. Okay, so in essence that 8 volts is what you'll be getting with the other frequencies like 30 hertz, 60 hertz, 70 hertz, and that's almost the same voltage as the normal, you can say the like normal channels without being bridged. Okay, at max. So now I'll be doing the bass boost and just see what I get. Okay, it's 13 volts. Okay, showing me a signal there. It's 36.4. So I'm just gonna go back. Oh boy, that's a hard clip. As you can see there, it's a hard clip. So at 36.3. Okay, that's the most I can get out of that. Okay, 36.3 volts, and I want to put a clip max. Okay, now I'm gonna go a little bit back on the bass boost and just see where it starts evening out. There we go, around about 32.3 volts. Okay, so 32.3. Clean, and I want to put here boost it. Okay, now just to be sure, I'm going to turn the bass boost off so I get 8 volts again, and just to see that wave. Look, it's clean. See, 8 volts, it's clean. Okay, so the max you can get out of this clean wise is 32.3 with the bass boost on, but bear in mind that you'll be getting about 8 volts on the other frequencies, so there'll be quite a drop. Your box tuning will actually also help in raising the SPL score if, let's say, you're playing out of the bass boost area. So depending on where you're tuning, where your box is tuned at, ideally in a situation, a scenario like this, a 6th order would be ideal, or even a 4th order bandpass. If you basically gonna have it tuned at 50 Hertz with this, it can actually perform quite well. So now what I will do is I'll just do the math behind this, just to show you guys what this thing is actually capable of doing. Alright, okay, so now that's it. I'm done with the test. As you can see, that's the baby right there. So now it's over to the drawing board and the math. Okay, just another thing to note. Okay, this amp is a little bit warm after doing that test, but obviously this is, I'm testing max power one can get out of this, so it will actually get warm. But the nice thing about this amp is the little vent that's here, okay, for cooling. Another thing what I've actually noticed is I can actually, like, I'm playing a song now, and I can actually, if you put your ear basically right on this vent, you can actually hear the song itself, but very faint. It's up, you can almost hardly hear it, but you can hear those lyrics, but it's very soft. I don't know what that is. Maybe somebody can kindly explain. Maybe it's to do with signal to noise ratio, because that's also very important in the performance of your amp. Just another thing, like I say, there's so much to cover that I'm trying to remember what else I'm actually forgetting. Like in terms of the bass boost, okay, I think with the higher frequencies you would actually kind of maintain what the bass boost is actually outputting, because higher frequencies doesn't really need much power to get loud, so you find that you won't actually get much of a drop in that. But when you start playing below tuning, or where the crossover, wherever you set the crossover, which is 40 Hertz in this case, so going down 40 or 35, 30, 20 Hertz, that 8 volts and that will really play a big part in your reading. That's just what I think, because obviously highs, you don't need much power and you'll get loud. That's just how it is. So yeah, so now I'm just gonna do the math, and then we'll just look at it. What I'll do is, before I do the other calculations, I'll just quickly work it out on the phone just to show you, and then I'll just basically input what I found on the screen. Okay. Alright, now what I've got here is my Ohm's Law app open. So basically we're going to take what the readings we got now, which is the voltage that I got, and then the resistance. So resistance on these or the resistance on the value I'm going to enter here will be basically the value of whatever I'll be wired down to. So in this case it's a 2 ohm and a 4 ohm load. Okay, so the first value that I got voltage wise for this the channel, the normal channel, was 3 volts, and let's just say now I'm having it at 2 ohms. Okay, so at 2 ohms it will be a amp draw of 1.5 amps and 4.5 watts. Okay, now if I go and make it a 4 ohm load, it's then 2.25 watts and even less current draw. Now this is before I applied the bass boost to see what max I can get, and the max I could get, let's see, the max I could get was 15 volts. Okay, let's go. And if that I do it at 2 ohms, that gives me 112 watts RMS, okay, with a amp draw of 7.5. So that there, then I say okay, a 4 ohm load, that will give me a 56.25 watts. The other value of 8, which is the 1000 hertz tone, which gave me 8 volts. Okay, so 8 volts at 2 ohms. This is now with the bass boost on. Okay, it's 32 watts and a 4 amp draw. And then if I do it at 4 ohms, it's 16 watts. Okay, I don't know if you guys notice, the higher you go in resistance, obviously the less power you get out, and your amp draw as well kind of drops as well. So with this, bear in mind, like I say, there's so many variables and stuff that one has to actually remember. With that is when you connect a load onto your amp, as the subwoofer moves in and out different frequencies, the resistance of the box inside as well, depending on what box you're using and all that stuff adds to some sort of resistance. And 1 ohm is the least. Okay, 0.5 is the least you can actually go, even less probably, but let's just work on 1 ohm, not to complicate things. At 1 ohm, which is general, and your monoblocks, most of them are 1 ohm load, you'll get your maximum reading of the amp. So the higher you go in your ohms, the less power you get out of this thing. That also includes playing music. So you play music, you drop your dB level, okay, to about 1/3 of whatever you were setting it with a pure sine wave, depending again also on what dB you were using your adjustments. But when you play a song, it also cuts, okay, so it gets softer, and then as the sub moves in and out, there's resistance. More resistance equals obviously less power as well, box rise and all that stuff. So even that has to be taken in consideration of these. So this is, if it was a perfect world, like as is, nothing's connected, it's just what the amp can produce. This is what you are getting. But the minute you put a load on, it's a bit of a different story. Okay, so now I'm gonna do the calculations of the actual bridge when I actually bridged it for the sub. Okay, so now start off with the 8. Okay, the first reading is 8 volts, okay, which I've already worked out now. Okay, so I'm not gonna do that again. Okay, then that's before bass boost. Okay, so when I added bass boost, I got 36.3. so 36.3, sorry, so 36.3 at 4 ohms, because it's a 4 ohm load. It gives me 329 watts. Okay, which is somewhat impressive for this small little amp. Okay, you can cheat it, but I don't recommend doing it this way. This is if you decided, okay, you're gonna be brave and you're gonna actually, I'm gonna go 2 ohms on this baby. Okay, you're gonna get 658 watts. The amp will get very hot quickly. You might blow a fuse. It will go into protect. Yeah, so you can do it with 2 ohms, but you have to know what you are doing. Okay, I won't go into full details. I've done it a few times where I use a 4-channel and then I actually connect a 2 ohm load, but you have to do it right. Okay, and in case somebody says you can't do it, think of it like this: there's people taking 1 ohm stable load monoblock and then they wire it down to 0.5, and most manufacturers do not recommend it. Some will say, or some good installers will tell you, that you can get away with it if it's like a Korean amp. Apparently Korean amps can handle that type of abuse. But in case somebody says you can't do it, I mean, there's a perfect example. The monoblock 1 ohm, people wire it down to 0.5, and I think there's been people wiring it even lower than that, but that's for another video, another day. Okay, so now, and bear in mind, that's 36.3. That's hot clip. You saw how that wave was. It was clipped. Okay, so obviously I had to go back a little bit to 32.3. Okay, so 32.3. Okay, at 4 ohms it will give me 260 watts. Okay, which is pretty good. And I mean, it's like a 8 amp draw. Okay, sorry about the light dimming and like that. I'm actually using an LED light, so I'm trying to improve my lighting quality as there. So it's LED with what's it, the 18 volts battery. Okay, so it does that sometimes, it dims in that. But back to the to this topic here now. It's 260 watts. Okay, clean. Also remember, I was testing the battery alone without it being connected to alternator, so you still have to go to 13.6, 13.7, 14.4. so obviously now it might actually, and not actually might, it will push it maybe up to that 36, and then it's clipping. So obviously you have to be smart. Wherever it's not clipping, okay, then you just minus like 10% to basically counteract your voltage at 14.4 or 13.6. You'll probably get some clipping, but you'll be safe. And that's, again, like I said, that's a full tilt, 100% power, everything's 100%. Most of the times you don't reach your max volume, you don't reach full tilt most of the time, so it's not really a train smash that you have to worry about that much. Okay, so I was just showing you guys what this thing can actually do. Okay, my verdict on this little bad boy here is for me it's worth a buy. This brand of Powerbass so far hasn't disappointed. I've got the Warhead, the 20, well, again, inflated numbers, 25,000 watts. That's inflated numbers, okay. I still have to test that one, but I know that's about 2,500 watts RMS probably, or close, maybe 2,600. But I've got the Warhead, and I've got another monoblock of this Powerbass, the silver one. And so far I'm impressed with what the Powerbass can do. This particular one, this is another one, brand new, né? I've got another one that I use when I normally demo some of my videos there, with the towers for the home theater. I actually connected this one to the towers. That's what's pushing my towers actually at the current moment. And then obviously the subwoofer is a monoblock, also Powerbass, the silver one that I'm talking about. So my verdict at the end is, look, it's worth a buy. Obviously there is better amps out there in terms of quality. Okay, like for argument's sake, the Pioneer, can't remember the model of it. I'll be doing a review on that one next, because I've got that Pioneer, but that Pioneer is more suited for if people want SQ. This is more towards your SPL, like loud, get loud quicker, you understand? So it's not focusing too much on quality. Hence that's what I'm saying is when I put my ear here, I can actually hear music on this boards playing. So like I said, that's somebody that's more advanced with amplifiers can just explain that. I'm not that clued up with it. It's just I'm telling you what I see, okay, and what I hear. But yeah, it's worth a buy, guys. For the price as well, it's not that bad. I don't know how much it's going for nowadays, but if you want to run your mids, your tweeters, game, okay. I haven't really tested it with a subwoofer connected. I might do it later in another video. The type of boxes, if I were to connect a subwoofer to this, the type of box that I would go for would be efficient boxes, okay. If you go ported, you go big. You don't go for like boxes like sealed because of the airtight spring, because I'm not sure. Yes, it's pushing X amount of power, but I don't know if it's got that that driving force, if you know what I mean, that enough juice to actually really move it, you know. So I would play it safe and stay away from a sealed. I would stay away from a fourth because it's got fourth order bandpass because it's got a sealed section. The sixth order parallel, definite, because that's very efficient, okay. Sixth order series bandpass, okay, that one is tricky because it's quite stiff. It's a lot of pressure build up in that particular box, so you need power to really get the sub moving. So I would be wary connecting a sixth order series bandpass to this, but ported and a sixth order bandpass parallel would be a go-to box for me. And T-line, of course, yeah, T-line, super efficient, super efficient. If you got the space, definite. T-line is actually, I would even put T-line number 1 if you got the space. Okay, so right, that's it for now. What I would be doing is I will be loading the specs now, like on the sheet of what's on this here versus now what I have actually tested. And if you buy this amp and you've got a multimeter, okay, you can actually use the figures that I actually gave here for testing. I'll even put that included in that sheet form thingy that I'm gonna do at the end. Okay, so you can just take it because you saw where it clips and where it doesn't clip and all that. So you just connect your meter, and then you get the voltage, and then you know you're pushing X amount of power, and you know you're good to go. And then yeah, you just carry on. Okay, so that's it. So Noob Master out.